All right. Good morning, everybody. I can actually see you. One of the scary things in an audience or this big is they usually turn the house lights down and there's all this light on me and I can't actually see the audience, which is it's really strange just kind of speaking out into the dark. Appreciate your coming, despite the party last night and lack of water and so forth in the hotel. So let's see, I've got a long time here, so I'm going to relax and take things easy. And one thing I'm going to do, it's a little bit different. I know we've got some Q&A mics somewhere out there. I can't actually see them. I love to interact with my audience as I speak. So please feel free to stop, interact, ask me questions at any point. And that actually helps me to make sure I'm giving you the answers that you need. Before I get into my slides, let me give you just a bit of background of how I got into web services. I think it's kind of an interesting story. So I spent a couple years at Microsoft from about 1997 to 2000. And during that time, I worked on some very early web service tools and applications. I worked, if you remember, things like discovery files, disco files, had something to do with that. And I have this kind of very long-standing interest in programming websites and programming applications in the sense that after these things were shipped, it would be really, really cool if they had some kind of API so that interested developers could hook into them and go from wherever the developer left off and just pick up and keep on going. So web services were, to me, a very, very natural kind of a thing to add to a website. But back in 97, 98, 99, there really weren't any public web services to speak of. There were little kind of demo things like weather and stock quotes that kind of give you an impression of what it was all about, but certainly they didn't do anything really, really all that kind of mission critical. Left Microsoft to go out at the kind of the height of the dot-com boom to go work with some venture capitalists and help them to scope out companies and put companies together. And a lot of the companies that I went to look at were actually doing very early web services work. They were building SOAP tools and XML tools and development tools of all sorts that would tap into this alleged web services market. Because at that point, the best we could do, we would draw this picture. We'd draw the internet, we'd draw this big cloud, and we'd say, imagine in the future, at some point, there'll be these web services you can connect up to over the internet. You connect up, and you can use our tools, our applications, across the internet, over into these big public web services in the cloud, and amazingly great things will happen. We tell that story again and again, and people would look at us, and they'd say, yeah, right, I don't know if that's really going to happen or not. But we kept on telling it, and I certainly fell for it. It seemed like a good enough story at the time. And early 2002, I got the first inkling of the first Amazon Web Service. So I was lucky enough to get invited up to Amazon headquarters for a preview of this service, saw what they were up to, and suddenly that big cloud, literally that picture I'd been drawing for years and years and years, suddenly I could turn it from a cloud into something very real and say, Amazon.com, right there, public web services. Saw what Amazon was up to, decided I was really tired of talking about clouds and vaporware and so forth, and really wanted to be part of something a lot more real. So I managed to convince the Amazon folks to hire me. At that point, they really didn't have a gigantic web services team. They had a team of about 6 developers and a manager. Brought me on to another team that was kind of parallel to the web services team, and they said, go ahead and put just a little bit of your time into web services, not a whole lot, maybe 10%. Well, that 10% quickly grew and grew and grew, and they kind of signed up for a conference and didn't know who to send. So they said, oh, what the heck, just send Jeff. He can't do that much damage. So they sent me out, and before I knew it, I was going to talk after talk, and then they said, a little bit later, they said, you know, we got this position coming up called a web service evangelist, and we think you might already be doing the job, so maybe you should just interview for it. I figured, okay, that sounds kind of cool. Talked to my family. They said, yeah, let's do it. Interviewed for that, and before I knew it, in early 2003, I got these new business cards with the cool title of Web Services Evangelist. Since then, I've been doing literally what I do now. I travel the world, and I go out and I speak to user groups, I speak to conferences, I go meet with individual developers, just helping them to make sure that they're very well informed about what it is that we're doing at Amazon with web services. It's been a really exciting ride, but so far, from what I can tell, we're still closer to the beginning than the end. We've done a whole lot of really amazing stuff in the last 5 years, much of which I'll tell you about. But it sure seems as if we're just getting started. We haven't nearly exhausted the repertoire of possible ideas. Every time I go out and talk and I get to interact and work with developers, they give me some really cool ideas for even more things. And I take those and I write them down and I take them right back to the development team and say, guess what? I was talking to real developers and they said we need to do this and this and this and this. And they take all those great things and they put them into their product plans. And so I love the feedback. One of the things that's really interesting to me about conference talks, supposedly the company sends me out so I can come out and deliver the message. And I certainly do that. But the really great thing that happens is it opens up conversations. And I get to hear back from all the developers in the audience. And hopefully if you think this is an interesting talk and you blog about it or tell your friends and your colleagues, even more conversations open up. And to me, a lot of the value of what I do is the fact that I get to meet so many developers. I get to hear what they're doing. I get to hear their ideas, their concerns, their suggestions. So please don't be shy. Email me. You can Google for me and find me quite easily. jbarr, J-B-A-R-R, at Amazon.com. And happy to hear from you, happy to read your blog posts, and so forth. That's just a little bit of history to kind of tell you how I got to this point. And like I said, it's been just a really fun ride so far, watching us grow from this kind of little concept team at Amazon to something that's now headed by a senior VP with a large group of developers and program managers and so forth reporting in. We have this cool vision at Amazon we call web-scale computing. I'd like to start off by just showing you very, very quickly a few of the hundreds of different kinds of applications that our developer community is building. This is a really nifty site called SmugMug. They do premium photo sharing. You pay them an annual fee, and then they store your digital photos securely and reliably. They use an Amazon storage service called S3, and I'll talk a lot more about S3 in just a little bit. SmugMug has about 200 terabytes of digital pictures stored in S3. I've personally got about 19,000 of my family photos stored in there. Gigavox Media is the producer of a large number of different podcasts, including IT Conversations. They use 3 different Amazon Web Services, including the S3 storage service, the Elastic Compute Cloud, and the Simple Queuing service. They put those all together into a processing architecture where they're able to very, very easily ramp up to do their daily podcast processing, do that processing, shut down all their services, and so they have a very high peak load, but almost no average load. And we'll talk a lot about how that fits into web-scale computing as well. Linden Lab, the developers of Second Life, use Amazon S3 as their download support vehicle. Kind of interesting story in that they had been supporting client downloads from their own bandwidth, their own connections. At a certain point, they realized that their volume of downloads got to the point where they couldn't sustain their own connectivity. Without any planning, without any discussion with Amazon, they simply put that download up on Amazon S3. They set their download tool so it redirected over to S3. And in the first day of downloading, they did about a terabyte worth of downloads, just thousands and thousands of their client app downloads. And they do those things without talking to us, without any special business discussion. They're simply retail customers of the storage service. So one of the cool things about the web services, you step up to Amazon.com, you go to aws.amazon.com, you create your developer account, you put in your payment information, and you get your access keys for your services. You take those, you put those into your code, you're up and going. You don't need to come and negotiate with us. You don't need to have special business discussions. We don't have to have extended negotiation back and forth about how much of this and how much of that. It's a very, very retail kind of a business. You walk up, you give us your credentials, and away you go. And to me, that's part of the appeal, is making it very, very straightforward, very easy to get started. Basecamp is a project by a company called 37 Signals. They used several different Amazon services to support this project management application. They found that their needs for online storage were more than they could deal with on their own, switched over to S3, and saved about $1,000 a month on their storage costs. Okay, so let's talk about this idea of web-scale computing. One thing that we found that's really interesting, we found all these developers with these great ideas. They got the really cool ideas, and they have this vision in their head of the successful product that they can put out. Unfortunately, there's a whole bunch of really messy things that get in the way. We've taken all those things in the orange box, and we call that the muck. Basically, all the things that you need to do, that all your colleagues need to do, all your competitors need to do. Doing all of this perfectly only gets you to the point where you can really actually start to execute on your plans. You don't get a whole lot of kudos from your web surfers if you have great real estate costs, or if your servers are extra cool, or if they have really high quality power and bandwidth. It's simply the behind the scenes things that you have to do in order to just get to the point where you can start to do the thing you really, really want to do. Hardware, software, dealing with idle servers, because you're probably going to have a peak load that's far in excess of your average load. Finding real estate, getting data centers built, keeping all this hardware running, supplying it with power, supplying it with cooling, learning how to put these things in racks and get them connected, and dealing with load balancing, dealing with growth if what you do is at all interesting and you start to succeed, dealing with bandwidth, negotiating with bandwidth providers, dealing with just all the different aspects of hosting. All this is just icky, messy stuff that our thinking is we can probably help. We're doing this for ourselves at a very, very large scale. We've been doing it for 12 years. Our thinking is we can actually take our expertise, our servers, our bandwidth, all the fact that we have entire teams dedicated to each one of these functions, and simply make that available to you on a pay-as-you-go basis. So there's all kinds of interesting things that can happen once you're online. So every developer has this great idea. They say, I'm going to start small. I'm going to have this amazing dream where I'm going to end up with this really, really popular website, and the whole world's going to come visit. And they kind of think they're going to start small. They're going to be things will be quiet. And they're not quite sure how they're ever going to get to that point where they can actually deal with having this very large, successful website. But they always think, well, sometime between now and then, I'll meet a business partner. I'll get some funding. Some semi-magical event will happen that will actually let me actually deal with all this traffic. Sometimes that happens. Sometimes you build something so amazing and so cool that before you're really even ready for it, you wake up one morning and you're on the front page of Slashdot and Dig and TechCrunch all in the same day. And you've got a phenomenon I like to call a success disaster. You had this great dream. You were just so sure that the whole world would come visit you and love what you did. And unfortunately, they all do. And instead of it being that really, really fun day of your life, and you're just so happy that your vision has become real, instead, you're just kind of in despair because all this traffic's there and you just simply weren't ready to deal with it. You scale up and you find that by the time you've scaled up, people have moved on to the next bright and shiny thing, and perhaps you've overinvested in infrastructure. So this rapid, unexpected customer demand is something we think we can help you to deal with. There's kind of the typical chart, and I don't even know what website this is for. A website suddenly becomes very, very popular. You get this gigantic spike in demand, and a lot of times developers simply don't know what to do. They don't know how to plan for it. They don't know how to test for it. They certainly can't afford to scale up in advance just in case it happens. Or maybe you have a business with seasonal spikes. Here's the traffic report for Amazon.com, and you can see that leading up to the holiday season each year, we seem to get a nice, good spike kind of late in the year, November, December-ish. Not quite clear why the traffic trailed off so rapidly after the end of 2006. I suspect there's some measuring anomaly here, but you can definitely see the spikes there. And if you've got a seasonal business, having to scale up to the point where you can deal with these spikes that might last only a week or two per year, probably not economical for you. Now, I'm the last person to make fun of somebody else's difficulties, but I did find this article very, very relevant. So Intuit puts this product online called TurboTax, and last April 14th and 15th, it seemed like every tax filer in the US wanted to get to their product at the same hour. And this to me was an extreme example of how scalability can be a real interesting issue. So this quote says, every year we take the busiest minute of the busiest hour of the busiest day and build capacity on that. So that's pretty amazing. So they're actually thinking there's 1 minute out of the entire year that's their busy point, and they need to actually have servers that are effectively sitting idle just for that 1 minute of the year. That can't be very economical for them. Those servers are just probably sitting idle for most of the rest of the year. Nobody is going to be filing taxes in any other part of the year. So this is a perfect use case for our web-scale computing model, simply using resources as you need them and not paying for them when you're not using them. We've been doing web things at Amazon for 12 years now. And we found that all those things in that box I showed you a few slides ago, that's about 70% of the work. We call that the undifferentiated heavy lifting. The things you have to do and the things that all your competitors have to do simply to get to the point where you can actually start to do your unique value creation on top of that. So 70% is a pretty high amount of your effort to invest. Our thinking is that we can give you the right services so that you can pretty much put all of your time into doing your unique value creation. Count on us for the rest of all that ugly, messy stuff underneath, all that muck. So the idea here, we're going to give you several different web services. we call these infrastructure services, including the simple storage service, so you can simply throw bits up into the storage cloud, the elastic compute cloud, where you can rent servers from us by the hour as needed, the simple queue service, so you can have this nice buffering, this glue between your different processes, so that as different processors are running at different speeds, you can very easily use the queues to manage the workload between the processors. And then the Mechanical Turk, which is a programming interface or an API to get to human processing power. So as part of your very scalable website, perhaps you have some kind of a task you need to throw in front of people and ask them to help. Maybe you have an image upload site, and what you want to do is want to filter those images and make sure that they're suitable for your site. You could use the Mechanical Turk as your human processing element. You wouldn't have to have a whole room full of people standing by in case images happen to come in. You simply use the Mechanical Turk. You make a call and say, put this out in front of some person on the web that has proven they can do this kind of work, pay them this amount of money if they successfully do the work. So you can literally make it a function call and have a person do a piece of work. We'll talk a bit more about that later, of course. So wrapping all this together, we call it web scale computing. We offer you elastic capacity, both scaling up and scaling down. Very, very, very fast, both in the performance sense and in the ability to scale up very, very quickly. Always available because you're running on the same infrastructure that Amazon themselves uses. Extremely reliable. Very simple. So simple is the description of the conceptual model and of the APIs we give you. Of course, on the inside, these services are anything but simple. If you think for, let's say, inside of a storage service, you make one function call to store data with us. At the point when that function call is made, we take your data, we replicate it to at least one other server in the same Amazon data center. The call returns, so you know that your data is stored and it's redundantly stored transparently and in the background. After that, we'll then take your data, replicate it across one or more other Amazon data centers as well. So we do that for both availability, reliability, and scalability. Cost effective, and I'll actually talk quite a bit about pricing because I want you to know just how inexpensive these services are to use. And also low upfront investment. You simply sign up for these services, you provide us with your payment information, but you don't actually pay anything until the point when you start to use these services. There's no minimum cost, there's no minimum amount you need to use. If you use 1 penny's worth of service, you'll get billed for 1 penny's worth of utilization. On the capacity side, one interesting thing I always like to mention, when people think about scalability, they always think about scalability as how big or how gigantic of a website can I build, or how much traffic can I sustain. Sometimes scalability can actually mean how small of a site can I deal with. Can I have something that economically just runs for an hour a day? Can I have a storage mechanism where I only need to store a tiny bit of information? But perhaps that's part of some really interesting business model you've come up with. Let's say you come up with a very interesting, let's say, you find this kind of vertical slice where you say, I can build a very specific one-page website, I can put that online, and I can replicate thousands and thousands of them to deal with different little vertical niches. So scalability sometimes means how small is the smallest practical thing I can build with this, and we can get to the point where you've got even hundreds or thousands of bytes stored. If that's all you want to store, that's fine. We can deal with that as well economically. Any questions so far? Feel free to step up to the mics and ask questions. So what people see with this, and we've seen lots and lots of developers have great success. So there's all kinds of blogs you can check out that'll tell you how people are doing along this way. We've got a question coming up. Microphone live? There we go.
There it goes. So my question is, I read Doug Kay's architectural overview of how they're using Amazon at Gigavox. Very, very interesting. The big problem that he raised in the podcast with you was the lack of ability to store data. So supposing we have an engine that gets run at particular periods, and really our customers need to have extra servers, maybe double capacity, just to run that engine a couple of times a month. If we could put the engine out in your cloud and get the data to the engine reliably and quickly, and I don't have a solution for this, then we would be able to use it. And according to Doug, he couldn't use the S3 service to feed data. That was my understanding, to feed data into the compute cloud. I wonder, are you guys working on anything around that?
Okay, so I don't actually remember discussing that in the podcast. I certainly do remember sitting in Phil Windley's office and doing that. So S3 certainly has direct connectivity over to the compute cloud. And in fact, we don't charge for bandwidth between the different services. Not quite sure what he was referring to there.
Database stuff out.
Okay, so there's no Amazon-provided database solution. But what people have done, there's a couple different solutions. I'm aware of one developer that's actually Seattle-based who he's built a MySQL storage engine where you've got the MySQL SQL APIs on top, and the storage inside is actually Amazon S3. So that's one possible solution, and that's brand new. That was actually just announced at the MySQL conference last month, so I don't know that it's really a very robust commercial solution yet. It'll probably take a bit of time to mature. And there's also a white paper that we're going to be publishing relatively soon that shows how to configure MySQL in what they call the HA, or high availability configuration, where you can have multiple copies of MySQL, master-master replication between them, and then actually using S3 on the background to actually back up data into there.
Great. I'll keep an eye out for it.
Okay,
Thanks.
sounds good. Thanks for the question. More questions before we keep on going?
So if you want, is this live? Okay. If you want to not run the LAMP stack, but you want to run the Microsoft stack, can you put SQL Server 2005 up there?
Great question. Given that this is a Microsoft conference, I was expecting that. Okay, so we haven't actually put out our own Windows image. When we get to EC2, I'll tell you a bit more about this concept we call AMIs, or Amazon Machine Images. One of our clients, a developer client, has actually put together a proof of concept of running Windows Server 2003 on the Elastic Compute Cloud. I know that there's some efficiency concerns there because it is actually an emulation rather than running directly. But he did actually take the 30 or 60-day trial copy of Windows Server 2003, has that running on EC2, and it seems reasonably interesting. We're very happy to talk to Microsoft about getting Windows running natively, and there's some interesting licensing concerns, of course, because it's not running on real hardware. It's running on virtual hardware. But I'd love to talk to the right Microsoft folks.
It's the interesting licensing concerns that has me concerned. Just that simple. And I'm hoping you will make that effort, or they will make the effort, because as a Microsoft-type developer, it looks great, but how do I use it?
I share your concerns, and I'm very happy and receptive to speaking and making the right connections with Microsoft to get that to happen. I think it's primarily a legal challenge and a business challenge at this point, more than a technical one, and those are sometimes the more interesting ones to negotiate. Never thought in my training as a developer I'd end up mostly spending time on legal issues, but I could clearly see this as one of those things where we're going to need a whole bunch of interesting, business-oriented thought to make that happen. But happy to start that conversation if you know the right people to get started, or anybody else does. So these are the kinds of results that our developers see. And you can actually read in just innumerable different blogs that our developers have written without any provocation from us. They're happy to boast about all the successes they've had with our services. They get faster time to market. They can scale on demand. They can really focus on their product and their core competencies. They can invest their money in their unique business. They don't have to put money into servers and data centers just in case it might get used. They can actually we've been using this phrase pay-as-you-go to describe our services. We had a neat conference last week up in Seattle, and one of our presenters kind of misspoke and said pay-as-you-grow instead of pay-as-you-go. I think pay-as-you-grow is actually just perfect. That's a perfect description of how these things work. Faster pace of innovation, because you don't have to delay putting new features online because you don't think you've got capacity. And then we see happy investors because their money is going more directly to the business focus rather than to pay for hardware and pay for servers. So let's take a more detailed look. I'm afraid I'm going to fall off the stage here. I'm always kind of looking behind. Let's take a bit of a more detailed look at the various services. So we call the product that we've built AWS, or the Amazon Web Services. So we have a total of 10 different web services that go all the way from our core infrastructure out to e-commerce. And this is all running in the same data centers on the same types of servers, managed by the same operational teams that keep Amazon.com's own sites up and running. And we've spent about 12 years and about $2 billion putting all that infrastructure together. So it's pretty rock solid by now. We've got a great developer program. We've got 240,000 developers registered in the program. Very, very active, very, very open community there. Let's look at more detailed individual services now. So Amazon S3 is the simple storage service. The idea here is that, I'm missing a slide here. That's not good. There we go. Okay, simple storage service. The idea here is this is storage for the internet. Storage in the cloud, we've got essentially infinite capacity. You can simply throw data at us, and we've got the scale and the ability to take all of the data you want to send at us for as long as you'd like to do that. So storage for the internet, you store data in object form. So you send us entire objects that are anywhere from 1 byte up to 5 gigabytes at a time. You send us entire objects, or you download entire objects. After you download them, you can set an access control list on those objects so that you can very, very finely and carefully regulate who has access to them. By default, these are fully private objects. If you'd like, you can make them public for reading. So if you want to store, let's say, web pages or images or style sheets or JavaScript, you can make those public read. Every object in there has a unique URL, so very easy to use it for web storage. We have both SOAP and REST-style APIs for this and for the other services. And very economical. We've got a fairly simple pricing model for this. And let's review that. I think it's really important to talk about the pricing, even though this should be a mostly technical discussion. So you can look at these numbers and do the calculations for your own applications and your own usages and really be confident that this will actually be a good solution for you. So I put that little note up there as of June 1, because we actually reduced our prices with an announcement we made yesterday. We actually reduced the upload costs and the download costs. So we basically charge you 15 cents per gigabyte per month to store your data. So what that means, if you upload 1 gigabyte to us, keep it there for an entire month, we'll bill you for 15 cents. Each successive month, as you keep that same gigabyte in there, you'll get billed again and again for that same 15 cents. If you have a fraction of a gigabyte, multiple gigabytes, we'll calculate that down to the penny, and that's exactly how much you'll be paying us for. On the data transfer side, we charge you 10 cents per gigabyte to upload data, and then anywhere between 13 and 18 cents per gigabyte based on your transfer volume to download the data. So the transfer charge starts out at 18 cents a gigabyte. After the first, I believe it's 10 terabytes, it goes down a bit. After the next 40 terabytes, it goes down further. So you can see just based on the units of data transfer that we're using, we have some pretty large-scale customers using this. We also have a per-request charge that's anywhere between 1.0001 for, this is actually per 1,000 requests. A little typo on the slide there. So there's also a per-request charge. So if you put data or get data or list the contents of the data, there's a very small request charge there as well. And this is all charged through your regular Amazon account. Once we have your developer information, there's a tab you go to on your Amazon account, and we actually list each of the services, and we list your usage. You can actually download XML reports if you need to do any more fine-grained accounting, so that there's complete accounting and traceability there as well. So developers use this for all different kinds of things, from online storage for websites, to backups, to storing media and serving up media on demand, to dealing with scalability, where they're just very, very apprehensive about the possibility of one of these success disasters, and either in advance, which of course is the best way, or at the point when they suddenly see that gigantic torrent of incoming traffic coming, they push data up to S3, they adjust their URLs, and they can safely deal with scalability as needed. The next interesting service we have is called EC2, the Elastic Compute Cloud. The idea here is you rent servers from us on an hourly basis with no prearrangement needed. We have a set of... Weird. Okay, there we go. All right, so you get servers from us by the hour, no prearrangement. There's a set of web service calls that you make. Well, you can make web service calls to actually start up servers as you need them, list the set of servers that you have running, and then at the point when you are finished with those servers, you simply shut them down. We charge you 10 cents per server per hour for the actual hours that you need. So we can start up servers right now in a matter of minutes. So you make a call that says, please start up a new server for me. It takes between about 1 and 3 minutes currently to start up these new server instances. So if you can look a little bit out on the horizon, you see that tidal wave coming toward you. If you're manually managing your load, you can simply start up a few more servers. At that point, there's also a number of automatic load balancing and automatic scaling solutions that members of our developer community have put together, things that will automatically watch server load, and then up to some pre-configured maximum, we'll spawn up additional servers, And then when the load average on those servers gets back down to a tolerable point, it will then start shutting them down as well. So the idea is you've got very, very scalable capacity here. We use a virtual hosting environment called Xen, spelled X-E-N. And each of the virtual servers you get is the equivalent of a 1.7 gigahertz x86 machine, which also happens to have 1.7 gigabytes of local memory. It has 160 gigabytes of local disk storage, and then a 250 megabit per second network connection within the Amazon data center. At the heart of EC2 is something called an AMI, or a machine image. A machine image, think of that as your C drive or your boot disk, or your root drive if you're on a Linux system. And the machine image is simply the operating system, the command line utilities, any applications, any services, any servers, any pre-configured data that you would like to have started up on all these new machine instances. So if you think of the classic three-level architecture that people like to build, where you have web servers, application servers, database servers, you might actually set up separate machine images for those different types of architecture components and simply spawn up additional instances as needed. So one thing I have to mention, the scalability here isn't magic. You still actually need to build an application architecture such that it is scalable. Okay, we don't do automatic load balancing. We don't just start up servers for you automatically. We're giving you this raw processing resource. It's still up to you to figure out the right way to actually start up as many as you'd like, to share the load across them, and to then run the number that you need in the most economical way possible. You as a developer have full control of your machine images. You can use a number of pre-configured images that we've built. There's a growing community of images being built by our outside developers. And I do actually anticipate at some point in the future, I think that the very, very innovative commercial software developers, I hope, would actually figure out ways that they could create pre-configured images with their own software burned into these images and offer them to you on a pay-as-you-go basis. These machine images, of course, you actually create and you store into Amazon S3, and we do have a whole library of those available for you. 10 cents per server per hour, and then the same data transfer prices as I mentioned previously. Now, one really interesting thing, and I think very, very useful here, within the Amazon data center, if you build a solution where you might have, you've got your compute cloud, you've got some storage, you've got some queues that you're using for inter-process communication between your compute instances. We do not charge you for any bandwidth between those different services. So bandwidth inside the data center is free. And you glue all these different instances together with a service that is called SQS, the simple queuing service. The concept here is we give you reliable message transmission and storage. So you create any number of queues inside the scope of your Amazon developer account. Each of these queues is individually named, and you can set permissions and accesses on them. And you simply post messages to these queues. You can have any number of producers on one end of the queue, any number of consumers on the other end of the queue pulling data off of there. And you can, any message size, any number of messages, and you simply use this to hook up the various parts of your application. Charge per number of messages sent and data transfer charges on the queue. And I'll show you some examples of how this is actually put to use in real life. Okay, the last really great service for scalability is called the Mechanical Turk. This is probably the most unique of our services. So usually we have the people telling the computer what to do. Here we have an API where the computer can actually ask a person to do something. So API to human processing power. This is available at a separate site called mturk.com. So the concept here is that there's a few different actors in the whole scenario. We have this concept called HITs, or human intelligence tasks. So a HIT is a self-contained piece of work. So maybe we've got a website and we only want to collect up pictures of cats, let's say. So we set up this website, we ask people to post pictures of cats. Now we want to be really, really careful that we only have pictures of cats on this website. So we use the Mechanical Turk as our filtering mechanism. We create Mechanical Turk hits using this API, and we put a little question before a potential worker. We say, is this a picture of a cat? Yes or no? We offer them a certain payment as an incentive to do the work. If we're really, really concerned about getting a really, really high-quality answer, we might send that same question to 3 people or 5 people and then use a majority rules mechanism to make sure that we get the right answer from them. So these people, we make the API call. some person somewhere in the world that's a Mechanical Turk user finds that piece of work, decides that they can actually do it. They do the work. The answer gets returned to our website. We know yes or no definitively this is a cat picture or not. We release the funds to the worker who gets paid for it. So again, a great scalability solution. You've got a site where for maybe a short amount of time, you have a huge amount of work where you need a workforce. You can actually qualify this workforce. You can use a special system called qualifications, where you put rules in front of the workers, and you can say, for example, before you can do this kind of work, I need you to prove to me that you can read French, or you can translate English into Chinese, or whatever particular skill you need. You can test workers for these qualifications, and then make an annotation on their worker record so that you know for sure that they have these particular skills. So you put the human in the processing loop, and you basically, as the requester, if you're the company putting the work into the system, you pay Amazon a 10% surcharge over the fees that you offer your workers for doing the work. So we've seen just all kinds of different interesting things happen within the Mechanical Turk community. We've seen things like annotating street signs, where people look at pictures taken along roads. And these companies are doing geotagging. They say, look at these pictures of roads and mark every street sign, mark every drain, mark every crosswalk. Great way to get access to this workforce at very, very reasonable cost. A company called Casting Words, I'll show you a little bit later, uses the Mechanical Turk to get a workforce assembled to do transcription services for podcasts. Tons and tons of cool different things happening in that community. Now let's take a look at a couple different slides to see how you can build a real application with this. This is kind of the prototypical architecture that you'll see in a number of different AWS-powered applications. We've got some compute servers over on the right. We've got files moving back and forth at the top through S3 for storage. We've got queues that are both used to introduce work into the system and to then manage the work between various processing elements. And sometimes on the client side, we're both introducing messages to flow in some work, and we're uploading files into storage. Very, very common model. So let's see how this would work if we're doing some video processing. Okay, so now we're going to change that and say here's the actual Amazon services that we'd use. We'll use EC2 for our processing. We'll use S3 for storage. We'll use SQS for our queuing. So the client's got some work to be done. It uploads AVI files into S3. We push those files up there with one of the S3 APIs. And as it puts that work into there, it puts the files into S3, and it loads work requests into SQS. You can see those little boxes at the bottom, job 1, job 2, and so forth. So each time there's a new piece of work to be done, we simply drop a new message into the queue. On the processing side, an EC2 running instance is looking at the queue. It's always asking, give me the next message. It pulls the next message off the front of the queue, scans the message, and that message has presumably got some work encoded in there, steps through, and maybe that work says, take a file from S3, transcode it into a new format, store it back into S3. So here we go. We're actually processing job 1. We're processing that AVI file. Now, one of the interesting things about the queue is you can actually peek at the front of the queue. You can get the first message in there, make that message temporarily unavailable to other consumers. And so the idea is you peek for the message, you start working on it. If for some reason that worker application doesn't complete, if it dies for some reason, that message is still there. Another consumer can come along, find that message, and take another shot at pulling it off. So only when the consumer has actually finished processing the message does it pull the message off of the queue. So we got this consumer working on the AVI file. It does the work. Now suddenly we have an MPEG file that showed up there in S3 as a result of the work being done. So that's the basic processing cycle there. Now suddenly things get really busy. We've built this cool application. Lots of people are using it. And the client is busily stuffing more AVIs up into S3. It's putting more and more messages into the queue because there's a lot more work to be done. And EC2 is starting to get a little bit busy. That one instance that we launched seems like it's really busy. So there's a couple different things that it can actually do in order to regulate how many instances do we need to process. The most obvious, you could simply look at the load average on that server. If the CPU is busy all the time, that's probably a hint that you need some more servers to go. But people have come up with some more creative things to do. They monitor the queue length. If they see that the queue length is getting longer than some certain amount, they can spawn up additional instances. wait for that queue to drain, and at the point when it gets down to some low water mark, they can start to kill down some instances. Another way that people do it is they actually manage the queue size based on their service level. So what they'll do is, if let's say they have a multi-step work process, and they're going to have several different queues and several different kinds of processing on them. At the entry to the first queue, they'll put a timestamp on the message. They'll let that message and the work flow all the way through the system. At the very, very last step, they'll look at the current time versus that initial timestamp. They'll say, wow, it took 5 minutes, 10 minutes, whatever, for something to work its way all the way through the system. They'll take that time. They'll compare that against whatever's their desired service level. Maybe 5 minutes is too long and they really want it to be about 2 minutes. If things are running too slow, they'll start to spawn up some additional instances. And so that will presumably make the processing run a bit faster, because these kinds of things generally, when you put work into the queue, those are independent work units. There's no relationship between different items in the queue. So by simply adding more processors, we can consume more items at the same time and work on them in parallel. So if we see that if the processing cycle is taking too long, we add some more work units. At the point when it seems like things are running too fast, because then we realize we're spending money essentially for nothing because we probably have idle processors, we can start to kill off a few of those instances. So we've got developers that have implemented several of these different kinds of management strategies for their instances, and there's actually starting to be some commercial products as well that do this automatically for you. So here we go. The queue got kind of busy, so we launched a couple of additional EC2 instances. We'll start consuming all that data off of there very, very quickly. And we'll drain down that queue, and we start idling and throttling back on there. So there's room to very, very easily build these dynamic processing algorithms. You don't have to have all this hardware on hand to test it out. You can do experiment with these very interesting architectures very, very easily. We've got people that also do things like load testing. A very, very common problem with web applications. You design your architecture, you're pretty confident, pretty sure you've designed it to be very scalable. You kind of know what kind of database queries you're running, you know how long that they take, but you're not really, really confident of the performance at 10 requests or 100 requests or 1,000 requests per second. It can be very difficult to actually generate that synthetic load. Quite often you need a whole array of extra machines, basically just kind of hanging around for those relatively rare occasions when you want to do a load test. So EC2 is also great for doing scalability and load testing, because you put your target application up, you start spawning extra instances, and you might need to do an hour or a minute or a day's worth of load testing. You do that testing, you get your results. At the point when you're all done, you can simply kill off all those instances. Maybe it costs you $10 or $5, whatever, to do that whole amount of load testing. And you don't have any continued worry about having all that hardware around just for those rare occasions when you need to do that load testing. So let's take a look at some different customer solutions. SmugMug is definitely one of my favorites. So their challenge was that they really had this just unbelievable inflow of pictures, and they were tired of buying new hardware and racking hardware on an almost daily basis. So increasing customer demand, found that they could actually use Amazon S3 as their image storage. When I made this slide, they had 192, but I talked to Don McCaskill, who's the CEO and the chief geek, as he calls himself. They've now got over 200 terabytes of data stored in S3, and they're predicting that they've already saved $1 million and will save even more in the year to come. From their first exposure to S3 to the point when they actually had their application up and running and storing pictures, just about 1 week to get up and going. So that's one of the real advantages of having these clean, straightforward, simple APIs. The ramp-up time for developers is as small as we can possibly make it. So you can see that their daily page views just grew just unbelievably from 2003 on up to 2006 when they started doing this. Here's some more details of the economics that they saw. April 2006, they put S3 to use. From April to October, they went from 64 million up to 110 million images. And now over 200 terabytes, saved $1 million to date, and looking for between $1 million and $2 million in savings this coming year. Don McCaskill, who's the developer of this, he's actually at the conference. I don't know if he's here right now, but Don's got some great stories to tell about S3 and how well that's worked. Don, are you here? Maybe not. Maybe Don was at the party too late last night. Don writes a really interesting blog that you can read all about his adventures in growing and scaling SmugMug and his impressions of S3. One thing I'd love to be able to refer you to is our developer customers. We have a great community of customers that have taken these services, have built just this wide range of just, I think, amazing things, just very, very broad, very diverse. And by and large, they have good things to say about us, which is always great when you're the provider. You like your developers to actually like you and to be able to say good things about you. So I have no hesitancy whatsoever in referring you to our customers for more information about these things. Gigavox Media does podcast processing. So they didn't want to have a data center. They didn't want to have to wear pagers. They simply wanted to be able to do their core business, which is having a huge number of people recording podcasts, upload those podcasts to the Gigavox Media site, and to do all the processing needed to go from the raw podcast into the fully polished productions ready to go. They use 3 different services. They use S3, EC2, and SQS in an architecture very similar to the one that I just showed you. They spent about $100 on services during development. So they didn't buy any servers. They didn't have to deal with any of the hardware whatsoever. Their goal is to own no hardware. Took about 1 day to get S3 plugged in and a total of about 75 days to build their architecture. And this is the architecture that they built, so fairly complicated. And this is what people are building in the real world. Everything you see in that gray box there is running on an Amazon service in our data center. We've got S3 storage at the middle. They've got this control tool on the outside. What the control tool does is it manages the uploads. The uploads go to an EC2 server, an FTP server actually. Those FTP's data is then immediately pushed over to S3, and they put work units in a queue. Over on the right side, you see they have a transcoding server. This is an EC2 instance, or multiple instances based on how busy they are. Reads MP2 files from storage, transcodes them, stores them back over into S3. On the assembly side, so assembly is a really interesting process for them. So what they do is they take these raw podcasts, and then every day what they want to do, they want to put a fresh introduction, they want to put a series of inserts and advertisements, they want to put the raw podcast in the middle, maybe another ad or two at the end, and then the wrap-up, the conclusion at the end. They like to actually recycle their entire inventory every day, so there's a fresh set of advertisements, so you don't have stale old podcasts sitting there with out-of-date information in them. So they need to actually recycle them fairly quickly. I'd imagine that they probably want to recycle this like once a day, and they probably want to get it done in an hour or so. So for that 1 hour, they spin up as many servers as they need. They send the messages in that basically say, take a podcast, do the assembly process and put all the pieces together, store it back into S3, upload it to their outside content distribution network. They run that for an hour, so during that hour, they've got a bunch of instances running, they've got queues in action, they're accumulating, they're paying for that service as they use it. At the point when they're all done, those instances shut down, they delete the queues. Their only thing that they're paying for the next 23 hours to the next time around is for the storage for those bits. So they might have 10 or 50 or 100 servers running for that 1 hour, and after they shut them down, there's no cost to them. If they decide not to do processing on weekends, they simply don't spawn them up, and no cost. So this is actually I think one of the more interesting architectures, but turning out this is a really good model for the way people are using our services in real life. So they put this together in November 2006, and they call this infinitely scalable. They're confident that they can grow their business to any size they would like it without owning any hardware and with the ability to totally grow on our services. They realized that it would have cost them thousands of dollars to put the same infrastructure together themselves. And one thing that they found is that they don't have to carry pagers, they don't need to have operations people anymore, and they just have a lot less responsibility for keeping these things running on a day-to-day basis. They can actually go and take vacations and not worry about infrastructure falling apart on them. So really, really important for them. Casting Words, great example of Mechanical Turk in action. Their goal was to put a very, very inexpensive transcription service online. They did this using the Mechanical Turk. They put this together in about 24 days, and very, very interesting service. The way this works is you start out, if you have a podcast and you want a typed text transcript of it, you go to castingwords.com. On that site, you then give it either the direct URL of your MP3 file that you want transcribed, or you can give it a pointer to an RSS feed. If you give it the feed, it'll actually fetch the feed. It will parse out the individual podcasts in there, give you just a page with checkboxes in there. You go ahead and check off the ones you'd like. There you go to the next page. It then tells you, based on the length in minutes of that podcast, how much it will cost you to get the transcription done. So they charge 75 cents per minute for the standard processing and $2.50 per minute for expedited service. So you agree to the price. You then go through the payment process with PayPal. You pay them the money. At that point, what Casting Words does, they take your audio file, they upload it to Mechanical Turk as a hit, a human intelligence task, and they then have a pre-qualified workforce, people all over the world that have demonstrated skill at the ability to listen to these audio files, type out a text transcript, store it back into Casting Words, where it actually happens to get stored into S3. At that point, they have a raw transcript. They hand it over to another Turk task where they go through, they scan for typos, they apply some structure and some formatting to it, they do a final processing pass, and then I, as the requester, the one needing the transcript, I get an email notification back anywhere, usually between about 12 and 18 hours after I put my request into place. Here's my finished transcript. So there's people all over the world that are actually making money as Mechanical Turk workers doing this, and literally hundreds of other different kinds of tasks. So Casting Words, great example of Mechanical Turk in action. Okay, so that's just about the kinds of things I've got prepared, and would be happy to start taking some more questions. One thing that I love to recommend people to is check out our developer community. We're very, very proud of our community. We've got developer forums with tons and tons of good discussion, good back and forth, developer to developer, and then Amazon to developer. We have people dedicated, of course, to reading the forums and providing support. All the kinds of things that you need as a developer program. We've got sample code, we have getting started guides, cool code samples. We can refer you to people already using these applications in real life. We can give you case studies and show you how they're being used. Once you sign up as a developer, you'll get a newsletter. And we also run a web services blog on TypePad at aws.typepad.com. In that blog, we actually highlight a lot of the interesting things our customers have done. We really like we love to talk about the services, but we also really, really find it great to be able to point you to successful developers, because people still look at these web services and they kind of think, I don't know, is this science fiction or is this reality-based at this point? I love to point you at developers so that you can investigate, you can talk to them, you can read their blogs and say, this is real. People are actually building businesses around this, and they're succeeding with these businesses. So I do encourage you to take a look at the blog, take a look at our various success stories that we have, and actually see for yourself how well these things work. I'd be happy to entertain some questions now. I'll be around for, I think, into the mid-afternoon, and happy to talk to you one-on-one as well. So we've got some microphones, and we'll be happy to get some questions from you.
At the start of the section where you went through all the web services, you mentioned you had 10, but I think you only covered about 5.
That's correct.
You want to touch on maybe what some of the other ones are?
Certainly, would love to. Okay, so I only went through half, only because I think, even though I've been speaking for 5 years, I never know how long my presentations are going to take. So I'd rather not be rushed than to have to squeeze in too much. So the other services that we have on the e-commerce side, we have the first service we did was called ECS, or the e-commerce service. So this is the one that most people thought of as kind of classical Amazon. ECS is access to the Amazon product catalog. You can run queries against it, and you can say, give me DVDs or movies or books that match certain search terms. You can search by keyword, by author, by publisher. We return you a very, very rich data schema for the items that are in the catalog, with about 100 different data elements per item. We have another service called the Amazon Historical Pricing Service. This one's a bit more special purpose. This one's used by people that are in the business of listing and selling their own products on Amazon. The Historical Pricing Service gives them access to product pricing data going back several years, where they can actually look at marketplace pricing for, let's say they're listing a book. They can get pricing product by product, quarter by quarter. They can actually see, is the average sales rank and the average pricing of these products, is the pricing kind of trending up because the product is becoming more rare? Is the pricing trending down because the product is kind of dated and nobody cares about it anymore? We also have a set of 5 different services from our Alexa.com subsidiary. So Alexa's in the business of doing web traffic metrics. They actually do a web crawl every 2 months where they pull in about 100 terabytes of fresh data. They store that in an archive, and at any point they have a current archive that they're building. They have a full archive, and they have a historic archive. So these rotate every 2 months. We have search APIs that let you go and dig through that web archive. And in addition to doing raw searching, you can do things like exploring web connectivity. So you can start from a given domain or website, and you can make API calls and ask questions like, from this domain, tell me the places it links to, or tell me the places that link to it. Alexa also does traffic metrics, so you can get popularity rankings for domains. You can get speed metrics and reliability metrics from there. We also give you access to Alexa data such as most popular sites and thumbnails for sites. So those are some of the other services that we have. At this point, it would probably be like a 2.5-hour presentation to actually really do justice to all the wide variety of different services that we have. If you go to aws.amazon.com, you can find the full details. What's our next question? Here we go.
You talked about that when you host something in your site, you have to architect your system so that it knows how to do load balancing and stuff like that. Where can I read about it, or is there any architectural guidelines you have so that you can build your stuff, whether it is load balanced, how to do the load balancing?
That's a great question, and I don't have anything on the site I can refer you to right now. There's actually a really interesting book by the primary developer behind Flickr. I believe it's called Building Scalable Websites. His name is Cal Henderson. And there's various online bookstores. You've probably heard of some of them, that you can go and buy these books. We happen to run one as well. So Building Scalable Websites, I think, is the book. We're also actually in the process of putting together some more scalability resources. These are actually common questions that come up. And we've been hoping that we could collect up some best practices and give people some very, very concrete information about what it takes to build a scalable site. Because it seems like let knowledge has been kind of it's kind of held captive inside of the very successful sites. And if there's anything that we can do to expose it a bit and give it more access to developers, we'd be happy to do that. I was actually on an email thread with some people on my team yesterday, and we were just talking about this very thing of like, where can we get more scalability resources and make sure that we can point out to developers the right ways to do these things. So great question. I didn't hear that? The author, I believe his name was Cal Henderson. I'm sure somebody can do an Amazon search and find that right now. Next question. Going once, going twice. Okay, well, I will be around for, I think, until at least 2 or 3 o'clock, and would be happy to follow up with you individually. Appreciate all your attention and questions and so forth, and thank you so much for coming.